This is section 2.3, the composition of functions. This is an operation that is peculiar to functions. So, composition itself. Definition: let f and g be two functions where the range of g is in the domain of f. The composition of f and g, and it's noted like that, it looks like you've actually spelled the word fog. There's a little circle between the f and the g, and is read f composed with g is given by f composed with g of x is equal to f of g of x. The composition of functions is evaluating a function at a function. Composition is evaluating a function at a function. That's really what it is. We have kind of indirectly done that with a few things. Warning: in general, f composed with g does not equal g composed with f. So it's an example of an operation that does not commute, which really is not that unusual because if you think about it, division doesn't commute, 6 divided by 3 is not 3 divided by 6, and subtraction doesn't commute either. So composition is an example of something that doesn't commute. So some examples. For each of the following we're going to find in part A, f composed with g of x, part B, g composed with f of x, and in part C, f composed with f of x. And you will simplify your answers. Number 1, I have f of x is equal to x squared minus 4x plus 3, and g of x is equal to 2x plus 1. Now this example is going to illustrate something rather interesting about f composed with g and g composed with f. In general, they're not equal, and also in general, one of them is easier or quicker to compute than the other. So for part A, I'm doing f composed with g of x, which remember by definition, that's f of g of x. Okay, if I start from my innermost parentheses, it's technically x, so there's nothing I can do. So I move out to g of x. So the first thing I'm going to do is I will replace g of x by what it is. It's 2x plus 1. So I've replaced g of x by what it is. Now we've actually seen something like this before when we were evaluating functions. So we're now looking at f of 2x plus 1. So we'll back up here in our formula for f, replace x with 2x plus 1. So I'll have 2x plus 1 squared minus 4 times 2x plus 1 plus 3. Now remember when we were evaluating functions, we said if you had a mixture of letters and numbers, you had to carry it out further. So you couldn't stop after one step. So I need to square 2x plus 1, and I need to distribute the minus 4. Now again, to square the binomial quickly, square the first term, twice the product, square the last. Or if you need to do 2x plus 1 times 2x plus 1 and do FOIL, that's fine. But if I square it quickly, I'll get 4x squared plus 4x plus 1. Square the first, twice the product, square the last. And then when I distribute the negative 4, I get minus 8x minus 4, and then the plus 3. I now combine some terms. Okay, 4x minus 8x will combine, and 1 minus 4 plus 3 will combine. 4x squared combines with nobody. So I have 4x squared. And then when I combine the 2x terms, I get minus 4x. And when I combine the constant terms, I get 0. So I'm going to have 4x squared minus 4x. Don't factor it. Remember, you do not factor when you're evaluating functions. The only time you factor is if the directions say to factor, or if you're trying to solve an equation that has an x squared or bigger, you set it equal to 0 and factor, and then set each factor equal to 0. Or if you're trying to multiply, divide, or simplify a rational expression. When you're evaluating functions, don't factor. Okay, for part B, g composed with f of x, which is by definition g of f of x. So the first thing I'm going to do is I will replace f of x by what it is. It's x squared minus 4x plus 3. So this means in our formula for g, where we see an x, so right here, we're going to put x squared minus 4x plus 3. So we're going to have 2 times 4x squared minus 4x plus 3 plus 1. Okay, you distribute the 2. That'll give me 2x squared minus 8x plus 6, and then the plus 1 on the end. And combine the 6 plus 1. So I'm going to have 2x squared minus 8x plus 7. Notice that one was a little bit easier than the f composed with g. That is what is typical. The answers are not the same, and one of them is a little bit easier or quicker than the other. Okay, part C is making me do f composed with f. So f composed with f of x is f of x. So, just like in the first two, the first thing I'm going to do is what's in parentheses. I'm going to replace f of x by what it is. It's x squared minus 4x plus 3. So I've replaced f of x by what it is. Now, this means in our formula for f, so again, going back up here, replace these x's with x squared minus 4x plus 3. So I'm looking at x squared minus 4x plus 3 squared, minus 4 times x squared minus 4x plus 3, and then plus 3. I have to square the trinomial, and then I have to distribute the minus 4. Okay, to square the trinomial, it's kind of squaring the binomial, you square each term, and then you do twice the product of each pair of terms. So if I square each term, I get x to the fourth plus 16x squared, right? Minus times minus is plus. And then square the 3, I get 9. Okay, now I want twice the product of each pair of terms. Okay, the first pair of terms I'm going to multiply is x squared times minus 4x. That gives me minus 8x cubed. Then the next pair, I'll do 3 times x squared. Okay, so I get 3x squared. I want twice that. That's where the 6x squared came from. And then the last pair I haven't done is minus 4x times 3. Minus 4x times 3 is minus 12x, and double that. That gives me the minus 24x. And then this came from distributing the minus 4. Minus 4x squared plus 16x minus 12, and then plus 3 in the end. So remember, to square a trinomial, square each term, and then do twice the product of each pair of terms. Okay, now if you want to do it like we did multiplying two trinomials, x squared minus 4x plus 3 times x squared minus 4x plus 3, and then do your partial products, you'll get the same thing. We're now getting ready to combine some similar terms. So x to the fourth won't combine with anybody. Okay, if I write it in order, I then have the minus 8x cubed. Then for my squared term, 16 plus 6 is 22, minus 4 is 18, so I'll have plus 18x squared. Then my x, negative 24x plus 16 will be minus 8x, and see my constant, 9, minus 12 is negative 3 plus 3 is 0. So I have x to the fourth minus 8x cubed plus 18x squared minus 8x. Again, don't factor. Number 2. F of x is x squared and g of x is x cubed. Okay, we're doing the same three things. So part A, f composed of g of x. Remember, that's f of g of x. So first we'll replace g of x by what it is. It's x cubed. So I have f of x cubed. In your formula for f, where we see an x, put the x cubed. So we're going to have x cubed squared. Remember, for a power to a power, you multiply the exponents. So 3 times 2, I get x to the sixth. Okay, part B is the composition the other way around. Part B, g composed of f of x. Remember, that's g of f of x. The first thing we'll do is we'll replace f of x by what it is. It's x squared. So I'll have g of x squared. Now in your formula for g, replace the x with x squared. So I'll have x squared cubed. And again, the laws of exponents. If I have a power to a power, multiply the exponents. 2 times 3, I get 6. So I have x to the sixth. That worked out to be the same in this example. F composed of g and g composed of f. Part C is f composed of f of x, which is f of x. So I'll replace this f of x by what it is. It's x squared. So I have f of x squared. In your formula for f, replace x with x squared. So I'll have x squared squared. 2 times 2 gives me 4. So my final answer is x to the fourth. Now again, how difficult it is to do composition comes down to, well, how bad are the functions? Number 3. F of x is 1 over x, and g of x is the square root of 3x minus 2. These look rather hideous. Okay, for part A, f composed of g of x, that's f of g of x. So just like before, first replace g of x by what it is. It's the square root of 3x minus 2. So I have f of the square root of 3x minus 2. Now in your formula for f, replace x with the square root of 3x minus 2. You'll get 1 over the square root of 3x minus 2. You can actually stop there. There's nothing else to do. If you really feel ambitious and want to rationalize the denominator, go ahead. If you do that, you would get the square root of 3x minus 2 over 3x minus 2. I don't really see any advantage to rationalizing the denominator. So notice if the functions are kind of nasty, there's not a whole lot to do. For part B, g composed of f of x. Remember, that's g of f of x. So replace f of x by what it is. It's 1 over x. So I'll be looking at g of 1 over x. In your formula for g, replace x with 1 over x. So I'll have the square root of 3 times 1 over x minus 2. Okay, 3 times 1 over x is 3 over x. So I'll have the square root of 3 over x minus 2. If you want to combine with one of the radical, okay, the LCD is x. So 2 would be 2x over x, so I'll have the square root of 3 minus 2x over x. And again, I see no need to rationalize the denominator. It's extra work to accomplish nothing. Number 4. Oh, what about part C? F composes f of x. So that's f of x. So replace f of x by what it is. It's 1 over x. Okay, if you notice what f of x does, it says flip it over. So this says flip over 1 over x. So again, if I actually use the formula, in the formula for f, replace x with 1 over x. So I'll have 1 over x, a complex fraction. The LCD of the simple fractions is just x. So if I multiply top and bottom by x, I'll end up with x. Again, all f does is flip it over. So I want to flip it over and then flip it over again. Now number 4. Okay, f of x is 2x plus 5, and g of x is negative 4. Once again, we're doing the same 3 things. So for part A, f composes g of x, which would be f of g of x. Okay, replace g of x by what it is. It's negative 4. So I would have f of negative 4. In your formula for f, replace x with negative 4. 2 times negative 4 plus 5. Negative 8 plus 5, I get negative 3. So negative 3 is the final answer for f composed of g of x. Okay, the composition the other way around. G composes f of x. Remember, that's g of f of x. Replace f of x by what it is. It's 2x plus 5. I now go to g and replace x. Ooh, there isn't one. G is just a constant valued function. So no matter what I give to g, I'm getting back negative 4. So g of x, constant value function, no x in its formula. Okay, part C was f composed of f of x, which is f of x. So replace this f of x by what it is. It's 2x plus 5. Now f of 2x plus 5 in your formula for f, replace x with 2x plus 5. So I'll have 2 times 2x plus 5 plus 5. Distribute the 2. 4x plus 10 plus 5. Combine 10 plus 5. 4x plus 15. Now let's take a look at some miscellaneous function examples. So just miscellaneous function examples. So I'm going to let f of x equal 2x squared minus 5x plus 3. G of x will be 4x minus 5. And h of x is negative 6. Okay. I want to evaluate and simplify. Okay, now I will show all 3 functions in each example that we do. So number 1, I'm looking at f of negative 4. So this is something from a long time ago. So in your formula for f, replace the x's with negative 4. So you'll have 2 times negative 4 squared minus 5 times negative 4 plus 3. Okay, now it's my dear Aunt Sally. Negative 4 squared will be 16, and I can do this product in the middle to get plus 20. So I'll have 2 times 16 plus 20 plus 3. Okay, now do 2 times 16. I got 32 plus 20 plus 3, which works out to be 55. Okay, so this is something from a long time ago. Number 2, I have f composed of g of 2. By definition, this would be f of g of 2. Okay, if I start from the innermost parentheses, which is just 2, there's nothing to do, so I work my way out. I have to first find g of 2. So first find g of 2. So g of 2 is 4 times 2 minus 5, right? So I get 8 minus 5, which is 3. So I now know I can replace g of 2 by 3. So f of g of 2 is really f of 3, since I found g of 2 to be 3. Now in your formula for f, let x be 3. So I have 2 times 3 squared minus 5 times 3. Looks a whole lot like the first one we did. Okay, square the 3, and I can also do the 5 times 3. So I have 2 times 9 minus 15 plus 3. 2 times 9 gives me 18, so I have 18 minus 15 plus 3, which crunches out to be 6. So f composed of g of 2 is 6. 6 is your final answer. Number 3, h composes f of negative 2. Now, if you're really, really observant, h of anything is going to be negative 6. But suppose you don't notice that. This would be h of f of negative 2. So just like in number 2, you'd say, oh, I got to do f of negative 2 first. It's inside the parentheses. So f of negative 2, in your formula for f, replace the x with negative 2. So 2 times negative 2 squared minus 5 times negative 2 plus 3. Okay, negative 2 squared will be 4. This product will give you plus 10. So I have 2 times 4 plus 10 plus 3. I get 8 plus 10 plus 3, which is 21. So I now know that h of f of negative 2 is really h of 21. And then you say, oh, gee, there was no x in h, it's just negative 6. So again, if you observe that from the very beginning, there was no need to go through all this. Remember, constant valued functions just give back that value. Number 4, I have fg of 0. Remember, fg is f times g, so I have f of 0 times g of 0. Okay, f of 0 times g of 0. So in the formula for f, let x be 0, and the formula for g, let x be 0. So I'll have 2 times 0 squared minus 5 times 0 plus 3 times 4 times 0 minus 5. So this one is f of 0, this one is g of 0. This works out to be 3 times negative 5, right? This is just 3, this is just negative 5. I get negative 15 as my final answer. Number 5, I have f plus g of negative 1. So this is going to be f of negative 1 plus g of negative 1. Okay, so replace the x's with negative 1 and f and g. So I'll have 2 times negative 1 squared minus 5 times negative 1 plus 3. So this one is f of negative 1, and this is g of negative 1, 4 times negative 1 minus 5. So this gives me 2 times 1 plus 5 plus 3. This gives me minus 4 minus 5. Okay, 2 times 1 plus 5 plus 3, that's 2 plus 5 plus 3. Negative 4 minus 5 is negative 9. 2 plus 5 plus 3 is 10. So I have 10 plus negative 9, which works out to be 1. Decomposition. So we're going to decompose the functions. We will be given that h of x is equal to f composed of g of x, and asked to find f of x and or g of x. Keep in mind that f composed of g of x is equal to f of g of x. Remember, that's what its definition was. Notice that g of x is the function inside parentheses, right? G of x is inside parentheses, and that f of x is the function that is outside parentheses. Also, in f composed of g of x is evaluated first, and then f is evaluated. Okay, now again, the parentheses are what really gives stuff away. In certain situations, you will actually see the parentheses, and in others, you will have implied parentheses. The implied parentheses are oftentimes like absolute values and radicals. Remember, on the calculators, as soon as you press the radical key, with the exception of one of them, it opens a parenthesis, and you have to close it. So that opening parenthesis is kind of the clue in the calculator. So you could actually put the radicand of any radical inside parentheses. In general, the choice of f of x and g of x may not be unique, but there is usually a best choice for them. Kind of the obvious choice. It is always possible to decompose a function. Let's try some examples. For each of the following, h of x is equal to f composed of g of x. What are the best choices for f of x and g of x? Simplify your answers. Okay, here's our first one. H of x is equal to 4x squared minus 5x plus 11, all to the 12th power. Okay, now hopefully you see something inside of parentheses. So the inside function is f of x, is 4x squared minus 5x plus 11. The outside function is taken to the 12th power. So that would be x to the 12th. So the function inside parentheses, that's g of x. The function outside parentheses, that's f of x. So g of x is 4x squared minus 5x plus 11, and f of x is equal to x to the 12th. Number 2, I have h of x is equal to the square root of 3x plus 11. Okay, this one has the implied parentheses. A calculator, the graphing calculator, makes you put 3x plus 11 in parentheses. So if we insert the implied parentheses, we would have this, the square root of, in parentheses, 3x plus 11. So now I have a function inside parentheses, 3x plus 11, and a function outside parentheses, the square root of x. So g of x is 3x plus 11, and f of x is the square root of x. Okay, now if you're just saying, oh, it's the square root function, you've got to take the square root of something, and that's what the x is, taking the square root of x. And let's try one more. Number 3, h of x is 3 over x plus 4 squared. Okay, so 3 over x plus 4 squared. Now there is something inside parentheses, namely x plus 4. This one, number 3, actually has two good examples, or two best functions. So we do have parentheses. G of x is x plus 4. And so f of x has to compensate for the square, so f of x will be 3 over x squared. Now if you'd wanted to, you could have said that g of x is x plus 4 squared, and f of x is 3 over x. That would also work. So in decomposition, the choices are not always unique, but there, again, usually is a best function for the f and a best function for the g. Now again, when you're doing problems, pay careful attention to the directions as to what are you asked for. Are you asked for both f and g, or are you just asked for one of them? That's the end of section 2.3.